Hi, everybody. I'm Xan Tronix, as I failed to introduce myself appropriately last night when I was making an ass of myself on stage. Some of you may know me better as Xan Tronix, but that's a boring name. Anyway, I'm going to be giving a talk today about Filesys POSIX, a mechanism that I use to create in-memory file systems entirely in pure Perl. You can use these file systems for testing purposes. You can use these file systems for archiving data using tar. You can use these file systems to serve data using WebDAV or anything that you wish to come up with. So this is the roughly the synopsis that I have in the Filesys POSIX pod. I will be going into this in more depth very shortly. Anyhow, why did I implement Filesys POSIX? Why did I need to implement something that has full file system semantics as it does? Well, it started whenever I needed a tar implementation, like tar on crack, basically, where I could modify the things going into the tarball in place without actually modifying the copy of the data on the live file system itself. So I decided to make myself a file system. A few interesting attributes of these of Filesys POSIX file system objects. Each file system has its own unique namespace, meaning everything has its own inodes. Everything has its own inodes. As you can see, you can get the attributes of the inodes like this using stat. And if I were to run that bit of code, it would look something like that. So I try to emulate POSIX VFS inodes as closely as I can within the constraints of Perl. Each file system object has its own file descriptor table. And I do use numeric file descriptors primarily for just sticking in the spirit of the Unix principle here. And of course, I do have a full suite of operations for performing I/O on these file descriptors. I can open a text file, much in the same way that you would in plain C, print something to it, close it, and there's a file. And of course, each file system object, of course, has its own path hierarchy. And by the way, the path facilities in Filesys POSIX, I did go to great lengths to make sure Filesys POSIX emulates the semantics of Unix file systems as much as possible. By the way, before I go any further, I should mention that Filesys POSIX is a terrible name for this module. The reason why is it really should have been named Filesys Fake. It doesn't really have much to do with POSIX the standard at all. That's fine. I'm probably going to re-release this module at some point in the future under a different namespace. But for now, let's continue with the talk. And of course, each file system has its own file system capabilities, and I'll show you more on that later. For instance, you can implement or you can import certain extension modules into a single file system object. So if for whatever reason you wanted one file system module to have a certain set of facilities and not another, then you can do so. For instance, I've decided to load a set of userland extensions that allow you to do some more interesting things like make path, and of course my tar implementation, Filesys POSIX userland tar. Within Filesys POSIX, I can set any ownerships and permissions that I would want because it is my file system. I have full control over it no matter what user ID or group ID I have running as any given process. Now, why does this capability matter? I will be showing you shortly, but everything does work as you would expect. I can even mount parts of the physical file system that this is hosted on into an instance of the fake one. This is really cool. So I can create the directory /mount I can create a new file system device object, which is the Filesys POSIX real. A device is an instance of this, by the way, and I can specify that it is to be mounted on /mount, and the path that I am going to coercively introduce into my fake file system is my home directory home Xan. I can also map individual files from the real file system into the fake one. This is very important because because obviously you can't mount a file in some location in Unix, and this allows me to add a single file in any arbitrary location, no matter what file system type I have under any mount point under Filesys POSIX file systems. This is really awesome for getting one-off bits of data and performing interesting manipulations that I'll talk about later in my talk. For instance, I want to do something very terrible. I want to map my Etsy password file into my fake file system. That's very easy to do, very straightforward. And as I mentioned earlier, I can generate tarballs from my file systems. So it really is as easy as creating an instance of Filesys POSIX IO handle just as a wrapper that handles buffering and other things, and passing any number of paths that I wish to tar up as the rest of the arguments to tar. I can even handle snapshots created from any point on my fake file system. So for instance, I can create a new directory, perform some interesting operations within that directory, and then mount a snapshot of that directory into any other directory. I can even mount a snapshot of a directory onto the directory itself. And this allows me to, I can do this any number of times. You know in Unix how you can mount a file system onto the same mount point as many times as you like. You can do that in Filesys POSIX too. And the really neat thing is, whenever you stack up snapshots like this, this allows you to unwind to previous states. It's really cool. I just talked about that. But this is what it looks like. I mount a snapshot. I touch a file. I mount another snapshot on top of the same directory. I touch another file. If I were to mount snapshot once, only the file mount snapshot bar that I created originally would disappear, which would be the first example, or sorry, the second example. If I were to unmount mount snapshot a second time, then everything in mount snapshot would disappear. I also have facilities for performing depth last finds, not quite as fully featured as file find, but it is enough for me to bootstrap my tar implementation. So this code example would simply print the entire, print all the names of the files in my file system, and if it's a directory, which I can easily ascertain with the inode object that is passed to each, that is passed to the callback for each file or directory or symlink or what have you, those are executed. Many features that you might expect from a Unix userland are available, such as the ability to set a UMask, so that the UMask will be honored for any files that you create. If you don't specify a mode, you can use stat. Stat returns a Filesys POSIX inode object that you can perform discovery on to see if it's a file or a socket. You can determine the mode, things you would expect. I even implemented makepath for creating entire deep hierarchies. And I also allow operations on inodes by referencing their file descriptor. And this is good if you want to perform atomic operations. And of course, I also have a concept of a current working directory. And that hasn't really been entirely necessary for me, but I'm sure other people, were they to be so insane as to implement a fuse wrapper for this, or something else, or a web server on top of it, it could be useful. Who knows? The inodes. Right now, there are some limitations in Filesys POSIX. All the inodes are kept resident in memory at all times. And if you're dealing with tons and tons of data, that may be a problem because those inodes, they can't be forgotten. Otherwise, the integrity of your file system drops. Oops. Mount points, as I mentioned earlier, work exactly as they do in Unix. Directory entries behave very similarly as they do in Unix. You still have the dot and dot directories for every directory. The path resolution semantics work precisely the same, so you can use ///, foo/bar/baz, foo/bar/baz, and it'll take you to foo/bar 2 directories up. All of that fiddly stuff works. And of course, you can implement multiple types of file systems within Filesys POSIX that expose the same file system semantics. All of this is nice. Apart from making tarballs, what can you do with it? Well, you could write a fuse module wrapper if you wanted to make it possible to mount a Filesys POSIX object in your Unix userland. It provides enough of the facilities that it would be very easy to do. You could even implement your own file system type to allow you to automatically generate files that are backed by code, much like the proc file system in Linux or FreeBSD or others. You can use these facilities to provide views of the same content from your real file system, but with different representations. I mean, you can do anything, really, anything at all at filesysposix.com. Nobody gets the Zombocom reference, I'm sorry. So the reason why I wrote Filesys POSIX, apart from being completely batshit insane, was the fact that cPanel uses Filesys POSIX to solve a very critical performance problem. Wait, that was backwards. Anyway, so I used to work I used to do migrations for cPanel. I still work for cPanel now, but in my previous capacity, I would maintain the code base that was involved in allowing our potential customers to migrate from competing control panel products to our own. And some of these programs that we deploy on non-cPanel servers to package up accounts in a cPanel native format, some of these scripts are very slow because they have to do some very nasty things. They have to do very terrible things to get the data in the format that we expect. I didn't like how much of a performance hit that these scripts were being imposed on our customers. They still need those servers to be up even though they're migrating from them if they want to have as clean a migration as possible. The real power of Filesys POSIX as cPanel sees it, I can use the various facilities to avoid as much as possible data duplication and heavy disk I/O. I can modify data in place without altering the original copy. I can generate account backups from non-cPanel machines in our own native format in situ. Things that you guys might appreciate if you are so inclined to mess with this. It's written in pure Perl with no non-core runtime dependencies. It works fine with Perl 5.8. This is very important because a lot of our potential customers, non-cPanel servers, do run Perl 5.8 because of CentOS. It's extensible. However, I do have some very notable limitations. It doesn't handle changes on a live file system, on an underlying file system host on the fly very well. I'll be implementing facilities for this later, probably using FS Events daemon on Linux. I'm trying to find a more portable solution. Unless you lock a directory you take a snapshot of, file systems state in the fake file system might become inconsistent. And this might cause some trouble for you. We've run into this in production whenever trying to migrate accounts live. So keep that in mind. And as I mentioned earlier, entire file system directory structures and inodes reside in memory at all times. This can easily exhaust all of your server's memory whenever you're dealing with hundreds of thousands of files. Plans for the future. What am I looking to do about those problems, and how am I going to make things more interesting for you guys? For one, I'd like to make the Filesys POSIX VFS module able to sanely handle an inode cache. So I'd really like to solve the problem of keeping the entire state of the file system in memory by having a sane cache and maybe backing that on a physical file. I'd like to implement support for real, actual, permanent block file systems that you would store on a disk. I would also like to port Linux's TempFS to Filesys POSIX and pure Perl. This might be really good for performance for people interested in doing mock-up file systems. I would also like, I didn't mention this on my last slide, I'd also like to implement full facilities for compatibility with Perl I/O, so that you can use plain Perl, makedir, and everything else in Filesys POSIX in a transparent manner within your tests. It's a work in progress. Feedback is certainly welcome. It's coming to GitHub soon, as long as as the powers that be do approve this. If you have any questions or comments or hate mail, you can email me at xan@cpan.org or my work address, aaron@cpanel.net. Don't be shy if you have any questions. That's all I have. Thank you very much.
Questions, folks? We are 3 minutes early.
Hi. Have you considered doing something like what Autodie does to basically overload all the Perl operators like open, print, and so on and so forth, to talk directly to this without a fuse in between?
That was actually what I was thinking about doing as one of the approaches for implementing the transparent layer so that you can manipulate Filesys POSIX objects without making calls on the Filesys POSIX objects themselves. Can you email me with your question? I'd like to address that in more detail because I don't have all the answers. Do we have any other questions?
To follow up with Reba's idea, you could then probably bind like event handlers on this and use it to like have file operations that come from other code actually go to something else entirely, like a message queue or Redis or something. Do you think that's possible?
I think that would be possible, yes. Please send me an email. Since we have 1 more minute left, I'd like to show you a demo. Very briefly, just a script that binds all of these ideas together. I have to import a few modules to provide the capabilities that I need for Filesys POSIX to do its job. I'm setting the UMask. I'm creating 2 home directories, fake and fake snapshot. I'm going to create a directory to store a portion of my real file system. And it looks like I created mount snapshot twice, maybe. Then I mount a snapshot of mount real to mount snapshot, as you see here. And then I'm going to create a few files in mount snapshot. One by using plain open and one by mapping my Etsy password into it. I'm going to touch a few more files using just plain touch. It does what you expect. And I'm going to go ahead and change the permissions on everything in mount snapshot to root, or the ownership rather. I'm going to do some stuff in the /home/fake directory as well, as I'm going to make a snapshot of that, just to demonstrate that effects that happen in a snapshot of a file system do not happen, or of a directory, do not happen in the directory underneath it. So at the end, I chdirt /. It's already, the working directory is by default / anyways. I'm just doing that to show you that you can do this. And I'm turning it up. So let me go ahead and run that just to show you the before. I have a demo directory full of things. So the demo directory that I'm going to be manipulating with Filesys POSIX looks a bit like that.
Manipulate fast.
Okay. So, as you can see, the tarball contains all of the very nifty and interesting things that I've done. I have fake foo in home fake, and in the snapshot, I had actually removed the foo file. That's not there in the snapshot directory. And of course, here's the view of the bit of my actual file system that I took in the real in mount real. So I have everything in there, as you might expect. Symlinks work, by the way. I even have a picture of Right Said Fred eating spaghetti, very sensually. I don't know why I have this. I thought it belonged in the presentation. And then, of course, in my snapshot, I have a few additional files that don't exist in the directory I created a snapshot of. So that's my nifty demo. There's many more things that you can do with this. So if you have any questions, once again, please let me know. And thank you very much for coming. I hope you guys have a wonderful rest of your day.